Hi, everybody. This is Lex, and here we are with another Azure on Air podcast. Today, I have with me Arnav Sharma. He's a Microsoft MVP and also a Microsoft certified trainer, all the way from Sydney in Australia. Move to the next screen, and I think it's up to you, Arnav.
Sure, thanks, Liz. So today, my name is Arnav, and today we'll be covering getting started a guide on Terraform with Azure. So how do you get started? What are the initial steps and kind of those things. So first thing first, we'll start with my intro. I've been in IT for like 17 years. I'm a Microsoft MVP and an MCP, so I focus on Azure tech stack along with 365 security, DevOps, and Terraform. I am a HashiCorp ambassador because I blog on the Terraform. I like Terraform that much, so I keep on blogging on it, and that's the reason I'm HashiCorp ambassador for last 2 years. And I'm a community contributor, so I contribute, I blog, I speak on different platforms, and the last thing, that's my website. So I blog on different technology stuff, cybersecurity, DevOps, Terraform, Microsoft products, kind of like updates. So I maintain everything on my blog. So that's me. Today we'll be covering Terraform. So first would be like how do we get started? What are the benefits of Terraform? Why infrastructure as code? The key concepts and how it varies from the other past technologies that we have used in past. So to get started, so first thing is infrastructure as code. So why do we use it? That's the first thing. Like you can go to the portal and click it yourself. Can be done a number of times, but there are a few benefits. The first is automation. That if you write a code or a set of like lines, I would say, and then you can reuse that code again and again. You can automate using DevOps,
Yeah.
any other tools. You can place that code in your Git repos, and then you can have version control. Like in case you're modifying a name of a virtual machine or adding a new resource, you can have that version control and even control who can access those files. Then is consistency. Like in case if you have a larger environment, you have 15 different type of requirements, applications, or let's say environments. In that case, you can have one code and distribute it across different environments. Like you can use the same code in dev, test, staging, prod, non-prod. So everything is consistent across the platform. And in case you are testing a code in one environment, you have that surety that it will be deployed across the platform. Then you have scalability, means like you can scale up and scale down or make do multiple deployments. Like for creating a single virtual machine manually, you need to click like 15 times. But let's say, and if you want to do 15 virtual machine deployments, so 15 into 15 is like 225. So kind of those things, if you want like to have the flexibility using IAC or infra as code, you just need to put in that how many VMs do I need, 15, 20, 500, and you don't need to do like repetitive test tasks again and again. And if you compare all those factors, the next thing is cost efficiency. Like you are not spending 15 hours deploying 15 virtual machines. You are spending 15 minutes to deploy even one virtual machine or 15 or 200 virtual machines. Saves a lot of time. Then is disaster recovery. Let's say something happens to your virtual machine or someone comes in and kills your virtual machine. For that case, if you have your code in place, everything is in place, what you need to do is just reuse it and deploy a virtual machine again or any set of resources. So any case, your data center goes down, or let's say one region goes down, you have the capability of disaster recovery using infra as code. The next thing is security. So let's say I am deploying a firewall and I don't want any person to deploy or create a star rule. So because of that, you can use Terraform like infrastructure as code and have that capability built within the code. So you deploy a firewall or a network security group, the components or the traffic is secured by default. The last thing is ISC tools. So there are different infrastructure as code. We'll be talking about Terraform here. But if you are from Azure side, you must be aware of ARM templates, Bicep coding, and then we have Ansible, Chef, Puppet, kind of those things. On AWS, you have cloud formation templates. So they do the same thing, but they are like they can be vendor specific. And let's say you are a perfect developer in AWS. but you don't know anything about Azure. But if you know Terraform, you should be able to do the deployments across multiple platforms. And then it's Ansible, Chef, and Puppet. They have limitation and capabilities that can be leveraged. But if you are using Terraform, uh, that we'll be discussing today, what are the different like features, benefit, and kind of those things which we can leverage out of Terraform. The next thing is Terraform. Alex, you want to ask me? Yeah, but
Yeah, no,
yeah,
yeah, I mean, with the previous slide, it's clearly all about predictability, right?
yeah,
Using IAC. Uh, wow, yeah, you want to deploy any kind of resource just always in the same manner, as long as you know that the configuration is fine. Yeah, that's really what you want to achieve, right? So that's
yeah,
yes, that's pretty much key, of course.
yeah, right. So a couple of benefits for Terraform over other technologies that we have, let's say ARM templates. So first is the syntax. So with Terraform, like you just need to learn how the code works. The blocks are same, the coding is same. You don't have to worry about comma and those things, which were like a bit of pain when you were using ARM templates, JSON, YAML, kind of those things. But with Terraform, you just learn the syntax. Even let's say you are a AWS guy, don't know how to deploy a VM in Azure. So you don't have to do much. You just need to learn the Terraform, and you will be like multi-cloud professional after that. And then is the consistency. So you can have consistency. Let's say you are a big company and you are deploying virtual machines in AWS, Azure, GCP across the board. So in that case, you can use Terraform to do the deployments, and then you can have configuration within the code that if my VM is deployed in Azure, GCP, or AWS, the maybe let's say the type of screw or the hard disk number of hard disk remains the same. So that's the benefit. The next thing is modules. So what we can do is like we can create modules from Terraform, and you just need to change the inputs that you are supplying. That let's say my VM name in test is test01 VM, and if you are using the same code in prod, so you just change the name and the backend code remains the same. So modularity is another good benefit which other tools don't provide as such. And the next thing is ecosystem. So in the demo, we'll be looking at Terraform registry, which gives you all the providers, the target with target components which you can target like GCP, Azure, VMware, even firewalls you can target using the ecosystem that Terraform registry provides. The next thing is state management. With Terraform, the unique benefit is the state. Let's say in your company you have 15 different people who manage Azure resources, and some people don't like code and some do like code. So let's say you have deployed something using code, someone goes in and changes the things around, let's say adds a disk or expands the scope of the virtual machine. With Terraform, what you can do is when you're doing a deployment, you'll be able to see what has been deployed and what has been changed manually. So Terraform tells you that this is my state. My code was used to deploy a virtual machine of this school, this many hard disks, but things have changed. So it gives you a trackability of like what has been changed, what has been done, and it maintains everything in the background using the state management features that the feature that it has. The next last one is scalability. So with Terraform, you have a couple of features like count. So count and couple of loops which you can use to do multiple deployments. Like let's say I'm a bigger organization moving to cloud, and I have a requirement of like let's say 15 different virtual networks connected back to the on-prem or kind of those complex environments. With scalability, what you can do is you can start with let's say two deployments at one go, and once you have done that, the next thing will be uh, expand that uh, expand that capability to larger environments. So it gives you scalability right from like even for smaller organization to bigger, and then you have the code ready, and it's pretty much flexible then how to use it. The next thing we would cover is the essential of Terraform, like what are the essential or how to get started. So first thing I would say is providers. Providers are basically what you are targeting. Let's say you are targeting Azure or Palo Alto firewalls, VMware, Hyper-V, kind of those things. So those are the providers. When you go to the registry, you will see heaps of providers, heaps of things which you can consume as is, and you don't have to worry about like how do you integrate your service with the code, kind of those things. So providers are basically what you're targeting, and the code, how the code interacts with the destination or where your deployment is. The next thing is resources. So a critical component of infra as code is your resources. The resources could be a virtual machine, storage account, a disk, a network, kind of those things. So with Terraform, you can have resource blocks. So let's say I am writing a code to deploy a virtual machine. But for virtual machine, you need a network, you need a NIC, you need like let's say IP address, kind of those things. So what you can do is instead of like having one page of code that includes everything, you can split up the bigger code or the bigger like components, the components into resources. So first my resources will be a virtual network, and then subnet, then a network interface, so I can have different uh, resource blocks, and that makes life easier because let's say you are deploying 500 resources, so you can split up the resources in small components, maybe even small files, that this file takes care of my network, this takes care of my VM, and kind of those things. So that makes life easier to maintain and reuse the code. The next thing is state, which we already spoke about. The state records any changes which Terraform makes to your infra, and the Terraform state needs to be secured, because if you're deploying a virtual machine, it will have a username and a password. The state will record the username and password as well. So in case like you log in and you make any changes, but Terraform will say that this has been changed and will try to push it back. So state takes care of everything. The next thing is the outputs. Let's say you're deploying a virtual machine with a public IP address, and public IP address you can't predict what IP address will I get. So outputs will help you out with those things. Or let's say you're generating a password during runtime and setting it on the virtual machine. So output will tell you that this is your password, this is your IP address, this is your virtual machine name. So gives everything on the interface that you are using. The next thing is the variables. So variables is like sort of inputs that we use in the code. So similar example is like I'm deploying a virtual machine. I have a module or I have a set of code that deploys a storage around a virtual machine, a database, and I want to use that code in 5 different environments. The first option is I do it 5 times, or other option is I use variables. I just say in the name that this is the name of my virtual machine in test environment, and this is the name of in product environments. So, and the last thing is modules. Module is like grouping the resources together. So let's say I'm creating a topology, or I'm creating a 3-tier app which needs a database, a front end, or back end. So what I can do is I can create modules. I can create a static code which sits in a remote location, or in a location which has limitation or RBAC controls or access controls. So what I would do is I would put in all the variables, all the code for the Terraform in one place, and from another location I can point that these are my modules. This is my source of truth, and these are the names that you need to follow. So it helps you like deploying environments, controlling how the things would look like, and how the deployment will look like in different environments. So if you talk about bigger organizations that have fully matured their journey towards Terraform or fully adopted Terraform, so that's modules is what they use generally. So you have modules, and everyone uses modules. There will be limitation on how many people would change the modules, but then you have different technology like Azure DevOps, GitLab, and GitHub to control those things around. So that's the essential of Terraform, the basic components. Any questions? Yes.
Yeah, so indeed, well, yeah, first off, that state capability
Yeah.
that comes with Terraform is really powerful, right? Just like I said, configuration can change over time, but still Terraform will be able, yeah, to understand those changes
Yeah.
and ensure that the scripts are being updated. Is that also something that comes with Bicep, for example, or is this unique to Terraform?
The state is unique to Terraform. With
Yeah.
Bicep, you do the deployment in case it would tell you that things are being changed. So let's say I'm the person who goes to the portal and change maybe the size of virtual machine.
yeah,
The Bicep will do a deployment, overwrite it, but Terraform will actually tell you that this is the delta between what has been done and what was deployed.
yeah, yeah,
That's
yeah, yeah. That's really useful. And then indeed, well, yeah, they have resources and modules. They both help, yeah, to organize your own work, right? But I did not yet completely get the difference between resources and modules.
Modules are basically many resources tied together. So you have, like, let's say I have a resource will be a SQL database, a virtual machine, a storage account. And if you combine all those resources together, you create a module out of it. So
Yeah,
it's
yeah.
it's
There's
based
really
on information.
grouping a specific, yeah, set of yeah, resources or scripts for those resources.
Correct.
Yeah. And how does it work then with modules? What's happening within modules? Because that is also about grouping resources, right?
Right. So another example is, let's say you are the application owner. You deploy a front end, then you have a back end, and then you have a SQL database. So those components will be resources, right? And we can combine all the resources, create a module out of it, and the benefit will be that I want to test it in multiple environments, so I can use that set of module, and module will have resources indirectly, so we can
Get
do
it.
multiple deployments.
Yeah, get it. Yeah, yeah, yeah. Yeah, very clear. Yeah, very clear.
So after this, we'll be looking at how to get started. So I've split this in like four steps. One is like installing Terraform. How do you create how do you download it? Where are the environment variables? How do you get started? How do you ensure that my Terraform is working? Next thing is, how do you authenticate with Azure? Because for Terraform to deploy anything on Azure, you need to have that connection between, like, authentication between your Terraform code and the target. So we'll see how we authenticate. Next thing is, we'll explore how the Terraform registry looks like, because that will be the source of truth in most of the cases. You want to deploy a new resource. Let's say you want to deploy a data factory. You have no idea what data factory means, how the code looks like. So you go back to the registry, find the find the resource that you're after, and then you deploy that. This is important because if you don't know how to move across the registry, you are pretty much like, you will be having hard time to figure out where my code is. How do you authenticate? Because different providers will have different mechanism to do it. With Azure, it will be pretty straightforward. We'll be using Azure CLI to log in. So, but let's say you have VMware and kind of those complex environments, different providers. So in that case, you need to ensure that you know the registry in and out, and how do you authenticate and read those stuff. And after that, once we have checked how the registry looks like, we'll be just pretty much copying the code and seeing how the deployment looks like. The deployment will have three steps: A, B, and C. One is initialize. The Terraform will check if your code is correct. It downloads the APIs and kind of like binaries to the local system. Then we'll plan it out. Plan is pretty much a command. These are three commands that we use. Plan will tell you what you are deploying, like we are deploying a VM, kind of those things. So in case there are modification, Terraform will tell you in the plan phase that this will be overwritten, or this will be destroyed or redeployed, in case you have to make manual changes. So once you ensure that everything is in place, you're happy with the deployment. The last thing is apply. Apply will deploy everything onto Azure. So that's the overall picture. How do you get started? The next I will do is, I'll move on to the demo. Any questions, or we good?
Yeah, I've been thinking this. How is it about licensing and costs? I believe Terraform, it is just free, right? Or at least there's a free tier that you can use.
Yeah, that's correct. You can use as is, like, the only thing is, if you're, let's say you're creating a tool, or the licensing changes that recently has happened. It's like, let's say I can't make my own product and sell Terraform, which is sitting under it. But if
Mm,
I'm a company, I want to use Terraform as is and do my internal deployments, I can do it. So
yeah,
that's
yeah, 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 yeah.
So first thing first, let's start with downloading the Terraform. So just search in Google, Bing, whatever your tool is. You look out for the first thing, which is install Terraform, and this will give you a page, a sort of a GitHub page. Like the looks is pretty much similar. So on the left hand side, you can select your OS, Mac, Windows, Linux, FreeBSD, OpenBSD, Solaris. So in my case, I'm on Windows. So I'll click on Windows. I have two options, either 64 or 386. So I have a 64-bit PCs. That's what is coming nowadays in the market. So I click on download, and download will kick off a zip file, and this zip file will actually contain a exe file. Let it complete.
Ah, the installer isn't it very big, right? What is it? 26
Uh,
megabyte.
it, it, it can be a small one. So this is how the file looks like. I have actually downloaded and copied the file in my C drive Terraform folder. So it is just exe file. If you click in, nothing will happen. It will just open up CMD and timeout. But this is how the file looks like. So once you have downloaded, the next thing is you need to tell your Windows that this is where my terraform.exe is, because if you type in Terraform, nothing will happen for now. For that, you need to do is set the environment variables. So just type in, like in start search, type in environment variables, and this will come in. And if you look at this thing, what I've done is updated the path variable to C type Terraform. So, and once you have done that, you have set up, so you need to reboot your system. So system reads it. Next thing is how do I ensure that my Terraform is up and running? The simple technique is you open a command prompt. Uh, you open a command prompt like this and just type in Terraform. So if your environment variables path and everything is correct, you'll get something out of it. If not, then you'll get an error that you're doing something wrong. So this is how the Terraform looks like. Nothing much to do in here, but it tells you all the commands like initiate, plan, validate, destroy, and other commands that you can use. But at this stage, we can't do anything out of just typing in the Terraform. So the next step is getting started with the code. But before you can start with the code, you need maybe, let's say, Visual Studio Code editor. So to keep a place where you can copy your code and like modify it. VS Code will be is free, so easy to operate, lightweight. So that's what I use on my system on daily basis. So we know how where the Terraform is running. The next important step is looking at the registry. So this is the URL, which is registry.terraform.io. So if you look at this thing, it like first page is providers, then is modules, then is policy libraries, and then run tasks. This is around like Terraform. You are using Terraform Cloud, but you can click on browse providers, or maybe if you know what you are using, just search it and you'll get it. But for this purpose, I'll click on the browse provider tab, and here I see everything that I can use and do the deployments on, like AWS, Azure, GCP, Kubernetes, Ali Cloud, Oracle, and the list goes on and on. So it's pretty much what you see, and then you have additional which are partner provided. So there are some which are certified, like if you see this icon like on the top, so that's certified by HashiCorp that you can use it. We know what you're doing, but there will be partner, third-party providers, and kind of those things. So partner has a sort of a partner sign, and there will be additional, like if you keep on scrolling to like page 85, you will see more and more providers, and that's how it works. Since we will be using a demo like deploying code on Azure, so I'll click on Azure. So this is the page how it looks like Azure, nothing in here. So it gives you a bit of stats, how many downloads have happened, how many downloads have happened in over the time. So a few things on the right hand side. One is overview, one is documentation, and use provider. So use provider will be your first step. So to get started with the code. So if you click on use provider, it will give you that this is the Terraform version you're using. Azure provider, like you can specify the options that use this and this, not everything, in case you want to limit like the uses of Azure. So this option will come in the later stages as well when you are deploying the code. So let's say I go to the documentation, and these are all my resources on the left hand side which I can deploy. So let's say I spoke about data factory. So let's say I want to deploy data factory. So I just type in the data factory, and you get this data factory resource. As we told that under it's subdivided into resources. So resources, and then you have data factory. It's different components, managed identity, data flow, kind of those things. So you can deploy right from the main resource to your like different components that are linked to each other. For simplicity purpose, let's say I'll stick on to Windows virtual machine. So that's my Windows virtual machine, easiest resource. But the complicated part is that Windows virtual machine can't be deployed on its own. It needs additional resources like network interface, yeah, IP addresses, and those things. But the good part is that with the documentation, it gives you all the things. Like if you scroll down, you have provider, which is my Azure RM. It creates my resource group. It creates my virtual network. It creates my subnet. It creates the network interface, and finally a Windows virtual machine. So those are the resource blocks what I was talking. So that's one resource block. That is another resource block. That's the third resource block. So with the flexibility, what I can do is I can create 3 or 4 different files and put my resource blocks in that. So in next thing, what I'll do is I'll move back to my VS Code. So that's how you find the code and how you interact with this thing. So what I'll do is I'll go back to my VS Code. So here I'll create a new folder. You can create it in the system anywhere, any location. So let's say I have created a folder which is Terraform. The folder is empty for now on, can be anything anywhere. So first thing is I have my folder where I'll be putting my code. So first thing is I create a file. So usually we name it as a main.tf. So you know that this is the source of truth and everything that's in here. And what I usually do is I create another file which is provider.tf. In provider, I can specify that I'll be using Azure RM as a book provider. The benefit is that you don't mix and match the code. Let's say these are my resources and this is my provider. If I'm using, let's say, AWS code, the file would look the same, but if someone comes in and wants to see how where I'm deploying, so straight away come onto the provider and read the things in.
Yeah.
So first thing I'll do is you go to the provider, copy this code, and that's it. That's the provider, save all. And the way this works is that I'll ensure that the code goes on to Azure and I have everything in place. Next thing is the actual deployment. So we'll be deploying the VM. So copy the code as is, come back to the main.tf and copy the code as is. So save all. So that's my complete code, or like complete Terraform code to deploy a virtual machine. So here, if you look at, let's say, provider is duplicate, I remove this. If I look at this thing, so with VS Code, what I can do is I can like work on a specific block at a time. Let's say I want to go on the resource group and I want to change the name. Let's say I want to make it RG demo 001, and I want to change the location as well. So I can pretty much play around with the resources, uh, play with the names of virtual network. Like let's say instead of example, I want to make it as a demo network, and same applies to other resources as well. So and if you look at the virtual machine, it will have your username, their password. What I can do is I can modify that, or I can generate those like admin password during the runtime. So I can add another block to generate a random string of 15 characters and then use it in here.
No,
So we can, yep, Alex.
no question.
Good. So the way this works is that you can do a link between the two resources. Let's say I am deploying, let's say, virtual networks, and I want to deploy the virtual network in my virtual machine in the network number one. So if you look at the network components, what I'm doing is I'm specifying that Azure RM network interface example.id. This example.id is the network interface, this one. So in case I'm doing multiple deployments, I can pretty much point that this is the subnet or this is the destination where you want to get deployed. So you can have linkage. And the other benefit with Terraform is that Terraform will look into the code, and in most of the cases when the resources are linked to each other, it will ensure that the virtual network is deployed first. After that, subnet goes. After that, we deploy the network interface. So it ensures that you have that consistency. But with other, like if you look at the ARM templates, there we had to specify that wait for the virtual network to be deployed, and after that you deploy this and that. But
Yeah.
with Terraform, it's way flexible. The other benefit is that you can specify the number of virtual machines do you need. So for that to happen, you need to specify a count variable. So it's pretty much sits in here in normal cases. So count and the number of virtual machines you want. But that to happen, you need to create multiple interfaces and needs bit of changes to the code. So that's how the code looks like. Other thing is the variables. I haven't created any variables in here, but to create that, you just need to create another file. For the name can be anything. It can be A B C D E F. The only thing matters is the extension. So I can create variables or variable. So defining is easy. So variable, let's say my VM name, and then I create a block in here. Then my block goes in here. So block goes in here. So what I can do is I can specify the default, the name of the virtual machine. Like let's say default default name of the virtual machine will be demo11001. So what I can do is, since I've created a variable, I can come back and here in the virtual machine code, I can specify that don't use this name, use my variable VM name. That's it. So using this case, I'm not hard coding any values, and I can have that flexibility of deploying the code using multiple different inputs. So that's the overall code, how the syntax looks like. So coming on to the next step was to authenticate using Azure. So in case you have not installed Azure CLI, the installation is pretty easy. Just go to Microsoft documentation, download the CLI. So to CLI, the command will be az.login and the tenant, like whatever tenant you are using. And then it will give me a different window in my different screen. Let me just log into that. So once I have authenticated, it will give me the subscription I have access to, ensuring that the access is in place and tells me everything. So I have two subscription, one is MVP and one is MCT. So MCT MVP is selected by default. I have an option to change it, swap it back to MCT, but I won't make any changes, just continue as is. So that's the first step. So, and you need to ensure that this directory contains all the files. So it contains main provider and variable.ef. So that's done. You are in the correct path. So first thing is you kick off the Terraform initiate. So initiate will download some additional files on the left-hand side. You will see some things popping up, the binaries, API, and those things. So it is initiating, it is looking at the providers. So it has created this folder will have license providers and different EXEs. So Terraform can leverage the code. So it has, if you look at the screen, let me just make so I did a Terraform initiate. It found that there is something known as Azure RM, obviously, and then it downloaded the EXEs, binaries, and now it has it has created a log file. Log file means any changes will after this, or in case you make any changes, will not be deployed. So that's my first step. The next step after initiate is plan. Plan can take a while because it is now checking with Azure side whether you're deploying the correct resources, syntax is correct, the SKU is available, kind of those things. And then after that, it takes a minute or two and it will give you a complete plan that I plan to deploy the resource group first, need to deploy the virtual network, need to deploy the VNet after that. So it gives you a plan. Uh, since it will take like a minute or two, do you have any questions, Lex?
No, no
Why?
questions. No, the concept is totally clear, right? And also, indeed, yeah, is totally aware of the dependencies. like you said, if you have a virtual machine, it depends on a subnet, an IP address, and so on. Disks and everything is nicely created in the correct order. So yeah, and that helps in your own productivity, right? You don't have to find it out yourself and bring everything in the right order. It's just taking care of you, for it by Terraform itself.
Right. Yep, that's correct. So it gave me an error that I need to specify the resource. Let me fix
Oh,
it up.
feature box.
I think I'm messing up. Let me just
Yeah,
open it and
something.
fix it back. So yeah, that's what I was missing, a feature block. So what I need to do is I need to do a Terraform initiate again. So it reads what I have updated. So same thing again. So what happened was that I didn't specify, like in case I want a specific feature from Azure, I need to create this block in all the cases and then tell that I want this and this feature. But for me, like it's pretty vanilla, a vanilla deployment.
Yeah,
So I pretty much created an empty block, which I was missing earlier. So after initiate, we do a plan.
yeah,
While we wait for this, maybe I'll just show around the this thing, the providers or the registry. So the good thing is, like people usually ask me that, let's say I want to do a deployment in Active Directory or Intra ID, or like I want to interact with app services or different, like let's say I want to create a website. So this is how you do it. You need to understand the resources that you need to use first. Like let's say I have a website which is hosted on a Windows web app or Windows. So first, I need to know that this is an app service which does that for you, and then you need to find that resource and then come back to the provider block, and then you this is where you find the like this is how you get started. So
exactly.
that's the thing. And other thing is, let's say you are not into Azure and you want to go back to, or you want to look into AWS side. So you come onto AWS and look at the documentation. Same thing here as well. So documentation remains the same, or irrespective of what you use, what you deploy. So let me see, that's still in progress. So let's say I want to deploy an EC2 instance. So I will go back and look out for EC2. There are heaps of options. I have no idea because never worked in Azure since a while, but I can deploy EC2 using Terraform, using the code as is. So let's say I want to deploy an instance, EC2 instance. I can pretty much come in here, what my code does, and uh, this is how it would look like. Let me go back and see if the code has kicked off. Yep, that's where we are. So I did a plan, and Terraform told that this is the Azure RM provider, and the plus sign says it will be created. If it is a negative sign, it means it will be deleted.
Yeah,
So it will create a network interface, and like all the things will be known after it's created. The reason being because it's not created, the IP address is not allocated, and like whatever these things are known after apply, you can do an output of it. Let's say I want to know what my public IP address of the virtual machine is, I can do an output. So it gives you everything, like the resource will be created, a subnet will be created with all the plus signs, and the network interface will be created, VM will be created. So everything is in one picture or one screen. And once you ensure that it is done, you can even see how many resources will be added to Azure. So the next thing is apply. Apply will is actually checking the same thing again. Like it will tell you that these resources will be applied or deployed, and then it will ask you for the confirmation that are you sure you want to go ahead, because in prod environment you don't want to delete your stuff and kind of those things. So that's what is happening. And in the meantime, if you have checked on the left hand side, it has created another file which is tf state, the state file I was talking about. It is still working on it, but as soon as it has kicked off the deployment, we should be able to open it. And this is pretty much the text file which you can open and see what Terraform has done for you. So let me see. Still working on it. So
Yeah.
once everything is in place, we have kicked off the deployment, we should be able to come back and see how the state file looks like and what are the deployments are happening. So let's give it another minute.
Yeah. 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 It's all yeah pretty straightforward. Everything right. Uh, yeah. Those are all logical steps that need to be taken. So that's be useful.
Correct.
And I assume that well, every single resource type that exists, at least in Azure, that can be deployed with Terraform, right?
Yeah,
Even if you,
that's correct.
yeah,
So
like maybe.
this is the next prompt that you get. So it asks you that, are you ensured that you want to deploy? Yes, we are very sure that you want to deploy. So once you have done that, type in yes, or you can do a control C and terminate it in case you're not sure. So once you have done that, it will start giving me a couple of lines that
Yeah,
Terraform is applying this and this. So give it a minute.
yeah, yeah, yeah. So there's yeah. So you really get the basic the boilerplate code from the documentation, and then after you have yeah copy paste it here in a separate TF file, you can just do all the modification that's required, of course.
Correct. So now you see on the screen that it's creating the things.
Yeah,
So it will even tells you that the resource group is created complete after 13 seconds. Network took 10 seconds and so on. So it will take another minute or so. But in the meantime, I'll just show you around. Let's say you're using Azure and you want to see what are my authentication options with Azure. So as you can like, this is the Terraform registry. So you click on Azure and documentation. So these are the resources, and this is like overview of the provider like Azure. How do you authenticate with Azure? So there are different ways how you can authenticate with Azure. CLI is what I was using. You can use the manager entity service principal certificates. You can use secrets or OpenID Connect. So different ways to do it. And the good part is it even gives you how to create those things or get started. So let's say I want to create a service principal and the client certificate. So if I click on that, it will take me to that page and give an idea how to get started, how to create a certificate, kind of those things. So the documentation is pretty good. And the only thing is you need to get started with the code. How do you get started? From where do you copy the code and do the deployments?
true.
So coming back to my code, so now it has created other resources. So what I'll do is I'll go to my Azure portal. So that's my Azure subscription. So this is the demo resource group which has been created in West Europe. And if you look at this thing, it has created a network interface, a virtual machine which is being created, a disk, and a network interface. So if I look at my virtual machine, it will have a status like still not provisioned or being created, kind of that state. So yeah, it says not ready. So not ready is still not in that phase, but once that's done, once my code is completed, so that's my 5 added resources. And when I come back, I'll do a refresh. So my VM should be up and ready in a running state, a proper state.
Yeah, it will be there, right? Just need something new. I mean, it's way faster than have to do it manually, right? So you shouldn't
Yes,
complain
the
too much.
benefit is like in case I want to do it 5 times, so I don't have to come back and click.
Exactly.
So that's my virtual machine. It's running, and this is the Terraform deployment. What just happened, and this is my resources, the resource group. Everything is good to go. So let's say you have the virtual machine and you want to output the IP address. Let's say the private IP address that has been assigned to the virtual machine. This out can I can use the outputs. So that's the overall, the bigger picture, how the Terraform work looks like. And let's say I no longer need the virtual machine. The last level is destroyed.
yeah,
So Terraform destroy is pretty much checking the state file again.
yeah,
So I should be able to open my state file. So this is how the state file looks like since the resources are deployed. Now it has tied up everything that this is my TF state, these are my resources. If I go back to Azure and make any changes, there will be a delta on what has been, what is in this file and what was deployed. So it keeps track of everything. So this is my complete state file. It will also have contain my username and password and credentials. So that's the reason we secure it in a remote location, a storage account, or even Terraform Cloud. So that's how the state file looks like. And once uh, I've completed the destroy, this state file will be an empty file after this.
exactly. Yeah, yeah, yeah. And so those are probably the commands that you use the most, right? Init, plan, apply, and destroy.
So yeah.
Yeah, yeah, yeah,
So yeah, that's so now it is destroying, and within like minutes, you will see the updated state file, and the resources will be deployed gradually.
yeah,
So I can come back, and it will go in a minute or so. So
yeah.
yeah, that's the overview of the Terraform, and yeah,
Yeah, looks very good, very useful. Yeah, yeah, yeah. Um, yeah, well, one question I was still thinking, this also what we discussed yeah, before this session today, actually. There has been that requirement from IBM of a HashiCorp company, right? That's a bit more than a month ago now that that happened. What do you expect? What will happen? Yeah, what is the plan of from IBM anyway with HashiCorp? Do you have any insights? What are your thoughts on that? Yeah, on what?
I think it will be too early to comment on that because but it will be good to see how the acquisition works because are they allowing HashiCorp to operate on their own as an entity, or it will be like merged together, like it will be like good to see how the things would work like because IBM has been there since ages, like since I was a childhood, I knew what IBM was. HashiCorp is something like last 10 years or so.
Yeah,
So it would be good to see how the big partners or big companies merge together and what will be the output for it. But I think at this stage it could be too early to comment how the future would look like.
yeah, yeah, yeah. Yeah, I mean, there must be a win for both parties, right? I mean, otherwise, yeah, HashiCorp also would not have it happened, and they really want to be an open platform, so you can use their technologies to deploy indeed to all those different yeah providers platforms. Um, well, it's hard to believe that IBM will touch on that, right? And just say, okay, we're just going to yeah lock it completely in. That wouldn't be a very smart move. So that's probably not what's going to happen. But it will be interesting to see indeed, yeah, what they will do with
Correct.
each company indeed, yeah, just like you said, the amount of freedom they get if they can operate just independently or really have to yeah dance towards the wishes of IBM. Time will
So
tell, probably.
we'll see how we go, but yeah, but that's our Terraform code. And since it said that it has destroyed few things, so I'll
Yeah,
go back to my portal, do a refresh, and see the VM, the virtual machine has disappeared. So a couple of more refreshes, and the subnet and other things have disappeared.
yeah,
So another refresh, maybe network will disappear, and gradually it will complain that the resource book not found. So it is destroying, still working on it.
yeah. Oh,
So that's my empty resource group, and maybe another refresh or two, and it will start complaining that you are in the wrong place. So the resource group doesn't exist. So it will be all gone. So if you look at the stage, it is deleting.
yeah, exactly. Yeah.
So yeah, that's how it works, how we deploy and how we destroy.
Yeah, yeah, very good, very good. Well, Yeah, well, I come from an administration background, and when I see this, I'm a fan. It's really useful. It's really powerful. It's just so much better than doing everything manually and yeah, finding out yeah exactly what configuration all needs to be applied and so on. This is really the way how you want things to be done right. It's much more predictable. Yeah, so it's just so much better to have yeah your complete infrastructure generated yeah via tools like Terraform. So big fan. Um, Also a good presentation. Nice style. Yeah, not the standard bullets. So looks really nice. Uh, yeah, you do it more often. Yeah, your PowerPoint like this with that such a style.
Yes, I try to keep it more interactive, so you have the pictures and those things, because I think if you keep on putting the text and those things, like people don't usually see that. So
No,
it's good to have different blocks and those things, pictures and steps. Yeah, that's how I do it.
yeah, yeah, correct. Yeah, yeah,
And that's done. All everything is destroyed, and if you come back to your state file, it is gone too. So instead of 300 lines, it's 9 lines without anything. So it's
yeah.
that's yeah, that's how it works, and yeah, all good.
Yeah. Well,
Cool.
thank you so much. This was indeed a very good introduction. Of course, it's not like Terraform is a new technology, but well, we still see a lot of new people joining. Well, yeah, starting developing the integrations, or at least the Azure solutions. And in all those scenarios, Terraform is just helpful, right? To create all this stuff and properly do it indeed, yeah, via AIC patterns. So that really is a good thing. Yeah.
Yeah.
Um, well, I don't know if there's anything else from you.
Yeah, I'm good. All good. I hope it was informative, and you know how the Terraform, how easy the Terraform is,
Yeah.
and yeah, cool.
Yeah.
Thank
Yeah.
you. Yes.
Okay. I believe there was indeed one final question maybe I have.
Okay.
Yeah, that was Terraform clearly is a cloud agnostic, or yeah, well, not just cloud, but it supports so many different providers. You've shown that in the website. But what if you would only be developing in Azure? Why would you still use Terraform over, let's say, yeah, Bicep?
See, what I've seen is if you're a smaller company, yes, for sure you can use Bicep. But as you grow, as you expand, so you need to have that capability to move to other places. Like, let's say I've 10 people right now. I have a small company, 15 resources. But in five years down the line, I acquire five new companies. They sit in different places, AWS, GCP, kind of those things. So if you have those bigger plans, if you plan to expand, if you want to scale up, then yes, Terraform would be the right thing to do. But in case you know that you will be selling only five things, you won't go that to that level expansion and those things. So yes, Bicep works as good as Terraform does, but few drawbacks.
Yeah. Yeah, true. And we've also seen that Terraform has specific features that are not yet, at least, there in Bicep, right? Like indeed, yeah, building up the dependencies. Uh, Again, the virtual machine, you first need to create, let's say, a resource group, and then the network stuff, and then the disk, and only after that you can provision the virtual machine, and all that kind of stuff is done automatically, right? Also, how
Yeah,
it deals with state, with well,
correct,
when your virtual machine yeah has been changed in a configuration, that it just recognizes those changes and
correct.
yeah, make sure that the scripts are being updated, and that's really powerful indeed. It might very well be that over time Bicep might also have that kind of features, but as long as it's not there, well, indeed, yeah, why not use Terraform, right? It's more powerful and needs, yeah, supports much more providers than Bicep, so that totally makes sense.
Yeah, yeah, that is. Hopefully, maybe few years down the line, Bicep would have a state file, could manage AWS, GCP. You never
Yeah,
know.
we'll see, right?
Yeah, cool.
Okay, well, I think, well, with that said, I want to thank you, yeah, for your wonderful presentation. Yeah, very clear explained. So thanks for being with us. And also to our audience, well, yeah, we hope that also this session was informative for you. And we will see you in the next one. Okay,
Sure.
take care. Bye bye.
See ya. Okay, bye.